Hello everyone, how are you today? Welcome to another show with Luciano,
And Roberto.
and we also have Ferris there. I don't know if you can see somewhere there. Okay, so today what we want to do is continue with our streams where we try to learn different things in Rust. And last time, what we did basically was a little bit of CLI, a little bit of processing zip files, a little bit of image processing. If you want to see the recording of that, is available on YouTube at this URL that you see in the chat and also here. And basically, today we want to change a little bit the topic. Roberto has been playing with Python and Rust and trying to integrate the two, specifically looking at an exercise of Advent of Code from last year that is particularly intense. So, doing it in Python was particularly slow. So, the idea is what if we can write some of that in Rust and then still run it in Python, but using mostly like a Rust based library to make it faster. And there are some libraries that we can see that allows us to do that in an easier way. So today we're going to try to redo all of this experiment together and try to learn something. I'm definitely going to learn something because I have no idea what's going to happen. I think Roberto is a little bit more prepared. So I'm going to let him drive for today.
Let's see.
We also have Eva4 in the chat. Hello, how are you? So
Hello.
I'm gonna share your screen. Is that okay?
Yeah, let's start explaining which exercise are we going to solve. So it's already solved in Python, but it's taking a lot. The exercise is this one. Are we there?
I can see your screen now. Yes, it's coming up.
Okay. Can I go? Okay, cool. Is day 19 from Advent of Code of 2022, so last year. Basically, you have robots. You start with one resource of ore, and you have to build with one robot. Sorry, I think each robot can collect one of its resource per minute, and basically you want to collect a geode. But to collect geode, you need obsidian robots. To have obsidian robots, you need ore and clay. And to have clay, you need ore. And to have additional ore robots, you need ore. So the game is, the exercise is the usual. I have an initial state. I can spend my resources in different ways. I have a branch in the possible state that then will branch again, and so on. And the question at the end of all of it is, it explains how it works. So it is the usual explanation of what happens after 12 minutes. The question is, after 24 minutes, what is the highest quantity of geode I can extract? And the input of this exercise is made. Where is the input? It must be somewhere. Is at the end. Yeah, path of input. Yeah, is this one. So we have 30 different configurations.
Okay.
In each configuration, the robot costs, they cost differently. So in configuration 1, to create one ore robot, you need 3 ore. To create one clay robot, you need 3 ore. To create one obsidian robot, you need 2 ore and 15 clay. To create a geode robot, you need 3 ore and 9 obsidian. Starting with 1 ore robot, what is the highest quantity of geode you can extract in 24 minutes? That gives you a number. We will have 30 of those numbers because we have to run for each line. We have to run a simulation for each line.
Okay.
We have to run a simulation, and this is so the simulation takes time. We have to run 30 of them. Is time consuming. When we are at the end of that, we have to move to give a number back, like usually in Advent of Code. That is, where is it? Determine the level of each blueprint using the largest number of the geode produced in the 24 minutes. And you have to multiply this number by the position in the blueprint. So blueprint 1 will be 1 multiplied by how many geode maximum you can get with blueprint 1 plus 2 for blueprint 2 multiplied by 12 in our example that gives 24. And then you go on like this, you sum everything together. The result of part 1 of this is 1427. Okay, so Python, like I said, the Python code is already here. It's not beautiful because, like always, advent of code, we rush out the code a little bit. What is now the problem if I run this code? The problem if I run this code is that it's slow.
Let's see. And while you do that, Eva in the chat is saying that she loves advent of code, but she made it only until day 8 or 9. I wonder if you're referring to last year ones, so 2022, or if you even tried some of the older ones.
So now what he's doing, okay, blueprint 0, in reality is 1. Obviously, we are off by 1 because it's beautiful to be off by 1. Maximum was 4, so this will be 1 by 4, 1 by 0, 2 by 0, 3 by 2, 4 by 2, and is summing everything. We have to do 30 of those. Like you can see, it's taking a while. While this goes on, let's look at the code a little bit, so we don't wait. Just
let us know in the chat if it's too small or if it's readable enough.
The font, okay, yeah, tell us something. So here is our input, blueprint, or what it was there in the browser. I wrote a parser function. The parser function is taking all the line in the input, is using a regex to extract the number of resources and the name of the robot. That in the end I don't use the name, but fine. I'm sending back a structure that is like this. I'm sending back a list of blueprints. Every blueprint for Python is a dictionary where the OR robot cost OR, and this is the number. The clay robot cost OR, and this number. The obsidian robot costs this OR and this clay. The gelled robot costs this OR and this obsidian. And I send it back. Then I have another function. Okay, in the meantime, we have the correct results in 98 seconds.
Sorry, Roberto, 99. Can you make it a little bit bigger?
Like this?
It's more readable for me, but again, chat, let us know if it's not good enough. Okay, typed reflection says the font is small. A little bit more. Can you do another point?
Another point.
Cool. Hopefully now should be readable enough.
Okay, I was saying, in the meantime, we have our 30 blueprints that run in 99 seconds, basically, giving the correct result. So 99 seconds, they are a lot. Where are we spending those 99 seconds? For sure, in the run blueprint function. The run blueprint function takes a blueprint. It takes numbers out of it. So max ore that we need for each robot, the max clay that we need for the robot, the max obsidian that we need for the robot. Is taking out of the blueprint dictionary into variables the various ore and clay needed for every robot. Is creating a stack as the queue. Our starting state is a bunch of numbers that are the robots, the 4 robots. So 1 OR robot, 0, 0, 0 for the other 3 types of robots. Then 0, 0, and 0 for the 4 types of resources, and 0 for the timer. We keep a set of the states that we already saw to be able to not don't follow that path if we already saw that. We keep track of what is the maximum number of geld that we were able to extract. We keep track of which generation we are, because we start from a state, we evolve the state, so we are at the 2nd generation, then we go to the 3rd generation, and so on. and we keep track of what is the number of GEOD that you should have in that generation. This is an optimization. Basically, what happens? If you are a state of generation 4 and one state in generation 4 has 5 GEOD, all the states in generation 4 that have less than 5 GEOD are states that are not good. So you can discard them because they are not going to be more productive than the state that is at the higher value. So we have to keep track of this. Then, while the stack is not empty, we go on extracting the state from left in our DQ. So we extract from the top of the VQ, of the DQ. If we already saw the state, we go on. If we reached the time limit, okay, how many GEOD I have? More than this, yes, then I set it. Otherwise, I have to evolve my states. To evolve the state, I look if this state is in the last generation. If it is in the last generation and it has less than the GEODs needed by this generation, you continue, so you don't evolve this state. And here you start. One way of evolving the state is just storing resources, not spending any resource. Another way of evolving is building an OR robot. So number of OR robot plus 1, but you have to spend the resources. And the timer goes on by 1. Then you can create a clay robot if you have enough resources, obviously, and you don't have more than the robots that you need, because clay, you can only build one robot in a turn. So it's useless to have, if the obsidian robot takes 4 clay, it's useless to have 5 clay robots, because you're already getting 4 clay per round. So why getting 5? And you are overproducing, basically, and we don't want to overproduce. The same for the obsidian robot and the same for the geode robot. And the end, we return our maximum. The Python code that is running this, so is just taking the time, because we want to print the time at the end. So we take the time. We start with our retard value to 0. We do for every blueprint in our parser, enumerating them, because I need I to multiply the position. Run the simulation on top of the blueprint. There is this print to see something happening, because otherwise you think that the process is just dead. And then you add the position. Remember that we need to add 1 because enumerate starts from 0. Multiplied by the number that we got back. That is our result. We print it and we wait for an input, for an entering on the keyboard, because, yeah. Okay, so what we want to write in Rust of this, the run blueprint function. So we want to have all this logic that now is done in Python, and this is the time-consuming part. We want to have that done in Rust. How do we do that? We start with this, the PyO3 library. Okay. Okay. Let's see what we have to do. We have to create a project. Okay, we already have a folder. We have to set up a virtual environment. Okay, let's do this. Let's go back to our... We are in a folder where there is only the Python file. See, there is only the Python file now. Let's initialize the environment. Yes, thank you.
Yeah, sorry. Meanwhile, I'm chatting here to see if I can improve the bitrate or something.
We have problems with the bitrate even tonight.
Apparently, yes. And it seems that my connection got a little bit slower, so I think I need to talk with my provider.
Okay, let's try to go on like we can. So now we are activating the environment, and we are installing Maturin. Maturin is a Python dependency. that will provide us with a tool to, I hope my internet connection is faster than yours.
Probably
because we
at
will
this
have
point.
to download a bunch of stuff. Yeah, I don't know. Luckily, they are not huge. They are not huge dependencies. So yeah, I have to upgrade people. I don't care. So what is the next command that we have to do? Maturin init. Okay, let's see. Maturin init. We want to use PyO3. That is one of the bindings for Rust, for Python, of Rust for Python. Yeah, okay. So you can use Rust inside Python. In theory, you can also use Python inside Rust, but tonight we are showing using Rust inside Python. Let's use PyO3. Initializing pim pum pam, it created stuff that we are familiar with. It created a cargo, a PyProject toml, it created a SRC, and inside there is a code. Obviously, we don't want this code, but it's interesting to look at this code that was generated. What is this code doing? This code is defining a function in Rust, telling, look, this is a function that you can call from Python, called sum as a string. Then you define a module, and inside the module, you add a function, wrapping it, you add this function here to the Python module that you will import from Python. So what we have now here? Now here, if let's go back to documentation, really better, but what we can do, yes, is a Maturin develop. Let's see what is happening. Maturin develop. Maturin develop will build. So it can take its time because compiling Rust is always compiling Rust. So it's compiling that libres into something binary. Okay. Found the PyO3 bindings, found CPython 3.10, using build options from PyProject toml, waiting for lock file on build directory. I don't know what is this. Building. Okay, there is something happening. Rust analyzer is building. Okay. There was too many people trying to build here through Rust analyzer building. Okay, he started. The lock was released from Rust analyzer.
So the only thing you needed to do in your code is just to create, well, to import this library and use the annotations, right?
Yeah. Okay, now we have, it's a installed PyO3 streaming exercise. Obviously, I choose a name that is super long because why not? Now, if I run Python from here, I can import the library. If I ask help about the library, it's not easy to see that here. Let me. Okay. This library contains a function called sum_string, and is the only exported function. Cool. So we are able from Python to import what we compiled. Now we need to do something else. We don't need to sum two numbers. We have to do something a little bit more complicated. So we call that run blueprint, like we called the function in Python. We give back as a result a U32. It will be enough. Let's see. If it's not enough, we can. And for now, we just give back an OK 0. Okay. Let's go to our Python code. We comment or we take this to the other. Let me think. What we can do is just. But well, let's not comment it. Let's just not use it. Okay. From. How are we called again? We are called like this from here. Import run blueprint as Rust run, and here we can call our function. Okay.
So this one will
It's
just
giving
give
zero,
you zero, right?
yeah, it's giving just 0, so the output obviously will be wrong, but let's Maturin develop. You can add -r to have a release version instead of the bug version of the code.
So Maturin develop,
It's faster,
does
obviously,
it recompile every single time, or does it do like a dev server?
Recompiles Rust, yeah.
Okay, so every single change you need
No,
to
it
rerun this.
recompile the library. Yeah, every time you change the Rust code, you have to run this to compile the Rust code into the library, and the library is installed in the current environment so that Python can reach it. And but well, there's a warning. I don't care. We will fix it. But now it will give an exception because we didn't fix the parameters. If we are passing a dictionary instead, it's expecting something else. Let's see how it explodes. Now Python. Okay, missing one parameter, positional argument B, because we. So instead of this, we don't want 2 numbers, but we want a blueprint of type. Now we have to go and see if here we have some documentation on top of the types that we can pass, because we want to pass a PyDictionary.
Exactly. Yeah. I wonder how do you do complex types between Rust and Python and Rust in this case.
Yes. There are a lot of examples here. For example, one that I find useful is this one. Hyperion.js.json, that is a JSON parser written in Rust for Python.
Okay.
If we go and look how this guy implemented the passing of parameters, okay, is a PyDict. There is a PyDict that is importable from here, and you can just accept a PyDict, a reference to a PyDict probably, because we don't want to do anything with the PyDict. Okay, let's see if a PyDict is what we want. Now I have to import that, quick fix. No. Rust Analyzer is sleeping. Consider importing. Yes. I want exactly that.
So it's not in the prelude, basically.
Okay, for now we want a reference. I say that, then I. Okay, let's see if now is better. Let's do our develop -r.
Interesting that you couldn't pass an actual value, but just a reference.
Okay, now it's super fast, but the result is wrong. Okay, but we run. So Python called Rust. Rust got a blueprint dictionary. It answered with a 0 as a U32 inside a Py result. Python got the number, made this stuff, and gave us the result. Now we have to write real code. I will take the Python code here as a reference, and I will do exactly what the Python code was doing. So here we will have to suffer a little bit. Okay, this is a list comprehension. We have to translate that to Rust, or probably we can do something simpler. in the end, yeah, we can extract the variables like here. And then we can get the max with from just 2 values without doing a risk comprehension. Okay, obviously this is not working in Rust. Also the variable is called differently. Let's go on. Here I'm getting a key. How do we get a key? Get item. Cool. Let's try get item or, sorry. I need to unwrap this guy. What is this guy? Rust Analyzer, do the miracle. Rust Analyzer is not doing the miracle. He's upset by my code.
Is it get item?
Let. Is an option by any, because doesn't know the type, because you pass a Python dictionary, so it doesn't know what is inside this key, because Python so it's a Python any, but it's also an optional because the OR key
it might be null or not exist.
Yeah, that. So let's go a little bit wrong. Now we have a PyAny. On this PyAny, what can we call? We know that it will be a dictionary. Can we call directly get item again? Yeah, or get on a PyAny, you can call get item because it could be a dictionary. Then if it's not, probably it just explodes badly. So at the end of this, we got a PyAny. Now, what we can do is extract this. To extract, we need it gives us a result of a no. Okay, let's try to do type inference. We want a new 32 from here. Is he happy about that? No, because it's a result. Okay. What can we call on result to get the integer? Luciano, do you?
Sorry, I was checking the stream settings there because still complaining about having pixelated code.
Sorry.
At least our cat is happy there.
Our cat is happy. Is the important part of it. I can unwrap. Okay, let's unwrap again.
Okay. And it's giving you a U32.
Yeah. Now,
how does it know that it's a U32? Because you said extract.
Because I wrote the type. So if I write the type, extracts know what it should extract.
Okay, so probably uses some kind of dot into.
Yeah, I don't know what it's doing internally.
Okay, otherwise you can probably use methods like as U32 or something like that, right?
There were format document. Okay, thank you. It was horrible. So yes, it's horrible even now, but at least it's more readable. Now we have to do the same for the other guys. Now, so we do the same for the other variables. I know that is horrible, but let's have some code. This is clay and ore. So, this is clay. Oops. Typo everywhere. Then we have this guy. We have always to tell that is after U32. This is obsidian ore. So this is first key obsidian. The second key is ore. Then we have this other variable. In the meantime, Luciano, if you want to tell a joke. No.
We need a joke API.
Yeah. You can ask ChatGPT about jokes about Berlusconi.
There are probably way too many about that. An API will not be enough. I wonder if we could create helpers at some point. Like you just pass the two items, the nested items, and does all of the
we can
stuff for you.
refactor that later, yeah.
Yeah.
Let's just start in the horrible way that gives the right result. Then we have all the life to refactor. But well, all the life, no, but sometime. Let's remember to tell which type we want back, otherwise we get a PyAny, and that is not a native type for Rust. Also, here I have a blueprint instead of a blueprint. And here we have Geld and Obsidian. And we can do this. Now he's complaining that here I didn't put a space between let and the variable name. Cool. Now, format the document. Thank you. Where are we? We are here. Now we need to do this code. We need a stack that is a vector queue, and we need a state. So let's create also the state. The state will have these fields. Let's copy the fields from Python. Let's go back to our start. Before here, we can create our struct called state that will have inside it robots, or that is a U32. Why the U is not working on my keyboard tonight? All of them, let's make all of them U32. So, for robots, for resources, one timer. The trailing comma is allowed in Rust. I don't remember it.
Yes, and if you format it, will add it by itself, so it's kind of expected.
Okay. What I should derive here? Should I derive something?
Depends if you want to clone or stuff like that. I think it's generally good practice to derive debug.
Yeah.
Let's then if you expect to clone, we can also clone. We can derive clone.
Sorry, what is complaining about?
Multiple fields are never raised. This is just a warning that we are never using these fields.
Okay, just give us a second. Okay, going back to Python, what we need to do, we have the state. We need to create a vector queue called stack. So let our stack be a vec the queue of state equal to vev the queue. This is why I never drive, because I can't drive. It's a vector queue new. Okay, then what we have to do, we have to add a state inside it with just one or robot. That is our, we can push anyway because it's empty. So, but in theory we should push on the back and pop from the front. So let's keep that. And our state is one. I can copy that from Python because it's the same. Or should I give the names in Rust? In theory, is smart enough, right? No.
I think you should give the names, yeah, unless you want to create a constructor.
Okay. Let's give him the name.
You could create a constructor if you want. Well, Copilot will probably do that for you very quickly.
I have my machine is already dying like this, I think. So Copilot, I don't think is an option. Also, is Copilot free? It's not free.
It's like 10 euros per month, something like
Too
that, or
much.
$10.
So now complaining that stack is not used. Cannot mutate immutable variable stack. Okay, yes, we need to declare that mutable because we are mutating the stack a lot. Trust me. Scene instead. Scene is a let mut scene is a set hash set. Sorry.
Okay, now if we want to put these values in an hash set, we'll probably need to derive hash as well.
Okay, now it will tell us something, I suppose. Yeah. Default is working here, or I have to do hash set new?
Should no, if to work, you need to also implement default into the state. You need to derive default, I think. Or maybe not, because maybe an hash set is just empty. Let's try. If you do
So you
default
say
before.
default.
Okay, it's probably just giving you an empty hash map, so makes sense.
Okay, let's go back to Python. We need those variables. We can just copy them and put a let in front of them, and a semicolon at the end. Semicolon, 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 let. Now we can return. Let's see if it infers the right one at one point. Okay, this one become a U32. Cool. Now back to us. Here we have the usual while. This is not while. While some state equal state equal to stack dot, and we say that we have to pop from the front. So pop front.
Which I can never remember in my mind if it's the first or the last.
I imagine we are pushing in the back and popping from the front. It's important that we just do the stuff in on the other side where we push.
Okay, fair enough.
Then let's say that for me, left is front and right is back, but who cares? Here we have this. In Python was a little bit different. We were doing while stack and pop left. Here we do everything in one go. Then let's do this if state in scene continue. So if scene contains
should be that, yeah. Why it doesn't like you today?
I have no idea. If we already saw the state, we continue. Yeah.
By the way, meanwhile, typed reflection is asking in the chat if you use pipe wire. I don't even know what pipe wire is.
Me neither.
Okay, because we came to the conclusion that it's your fault that the stream is not good. Sorry.
My fault.
Because it seems that your desktop stream, is coming through low quality because everything else seems better quality. I don't know. I know you're gonna blame Linux, but
obviously.
So I think for today, nothing else we could do, but next time we'll try to figure it out and try to have slightly better quality.
Contains because I have to derive a Q or partial Q. Okay, I have to derive hash partially a Q and also a Q. Everything.
Exactly. Yeah, that's the funny thing. So you can create a type that is an hash map of a state, even though the state is not hashable. But then the moment when you want to insert or read, it starts to complain like this is not hashable. I don't know why it doesn't complain straight away when you create that type. So probably the trait bounds are only when you start to use the hash map and not when you create one.
Okay. Now here, the funny part, we can't insert the state because we need the state for the rest of our journey. And also the state is not is short-lived because at every loop is going to get, I suppose, they are allocated. So for now, we can do an horrible hack
and just
clone it.
Yeah.
But now we have to derive clone
as well, yes. And because you are only using integers, it's easy enough, like it can derive it. Otherwise, every other subtype needs to be clone as well.
Ooh, we forgot something from the Python code, the maximums. Let's do them before we forget. So let max OR equal to, we have the OR of all 4 machines. So we need to get the maximum of this, and this. So we have to get the maximum of 4 variables. Okay. Remember that to me, we have a max function in Rust.
We do have a max in iterators. So what we can do we have an iterator, like a list?
No, we needed to create an iterator of the 4 variables, and we can do that. How?
Yeah, because otherwise I think you can only do a max with between 2 values. So otherwise you need to use an iterator. Yeah. So you could
mean
do
something like this.
If you use a value, you can do you can use the first one dot max the other one, I think. But we want to do it between 4 values, right?
Can I go on with the other dot max?
Actually, that's a good idea.
It's a horrible idea, but it's working.
It's probably better than doing an array with 4 values and then an iterator and then max.
But for sure it's faster computationally. So it's inferring, but well, until I don't fix all these errors. So the max clay, there is only one robot that needs clay, so I don't know why I have the max clay in Python. Yeah, the Python code is more flexible, but the max obsidian is the same. Okay, well, let's just copy the same exact code for now. Then we can optimize it. Okay, we were inserting the cloned stuff, and we are here. So now we have this logic. I will copy the Python one. We also need the time limit as a second parameter of the function. Here, time limit. Let's try to say that is a U32, okay? Why is complaining? Because we don't use it.
Just because we are not using it yet.
Yeah, and in the code, in the Python code, the default, there was the default parameter. If you look here, there was time limit, default parameter 24. Okay, we are just calling it in an explicit way. Okay, now we need the time limit. Where is it? Where are we? This jumping between languages is making me dizzy. If our state timer is equal to the time limit, nice.
So timer is basically the number of moves, the number of cycles.
Yes. Is greater than ret max. This is Python. We have to make then save our max, and we have to go on. Okay, there was an else in Python. Here we can do a continue to get rid of the else.
Mm-hmm.
And this is a state dot. So doesn't like it.
Cannot,
It must
yeah, it
be.
needs to be mutable.
They all need to be mutable. Okay. Here, what else are we doing? Another bunch of logics for optimizations. Let's copy and paste them and translate them. So here is gen.max and state.timer. At this point, it will infer gen as int. It was e32, is inferring that now. Okay, not still code that is broken. Let me fix it.
Yeah, I think it will complain about that.
Why?
I don't know if you can do a max between an i32 and an i64. Timer is an i64, right?
Everything is u32.
Oh, okay, then it should be fine.
If this and that, if state timer, because if we have everything inside our state, is equal to the generation and needs to be like this in Rust. State dot robots geodis less than generation. We continue. Continue at least is the same. So now they are inferred as a U32. Okay, magic. Where are we? Now we start to have the interesting part. Okay, we have to throw in just storage, no robot build. So, oops.
Okay, so you're basically creating branches with all the possible moves, right?
Yes, moment that this is not good for Python. I just want to copy, go in the other file, and paste. This is a comment. Now our stack needs to push back. Push back. What you need to push back a state. What was that story about the constructor?
Yes, we can implement one if you want.
Yeah, how it is the multi-cursor stuff. No, it was not this. No, it was not this. Guys, I'm terrible with multi-cursor. State new.
Yeah, well, we need to implement that.
Yeah.
But yeah, we can call it state new. So you need to do an implement exact state. And then curly braces, and you can do fn new, which doesn't take self, it just needs to take all the parameters. So copy paste. And returns a new uppercase self. So you need to add the little arrow. No, it's like an arrow. So dash and major. Yeah. And now you need to construct a new object passing all the values.
We have that. Okay, let's not be lazy.
This is one of the things that Copilot would be very good at. Actually, you don't even need to, because it's the same name, you can just pass the keys. You don't need to specify the values.
Okay.
So just delete all the type references.
So yes, it's not a lot of work then. Even if I was able to find a shortcut for the multi-cursor was not bad, but
guys, now the other idea could be because we need to generate a new state from an existing state, is that something that makes sense to implement as a method? Rather than doing it in line there in the code, rather than recreating a new state manually, I mean.
Yeah, but let's see the pattern because it's changing a little bit.
Okay.
There are a little bit of changes. So now is happy. Is happy. Okay, this is the no stuff to do. Then we have a logic and a new state, a logic and a new state. Okay.
Makes sense. Yeah, I'm thinking that probably doesn't make sense to do methods there because it's too specific.
There is a little bit of change to do because the other variables are called in the same way. We can take this code and change what we need to change. What we need to change? We need to change that we are creating an OR robot. So +1, and we are consuming this amount of OR to create it. So here is the creation of an OR robot.
Okay, that's the case where we could probably move all of this in a method, but I don't know if there is any benefit. We're probably going to do this operation only once, right? Because it's happening in a loop.
That one specific operation, yes. For the other robot, we have to do a slightly different operation with slightly different rules because. So this is the clay robot. I don't know if it's me or my keyboard.
Or both.
Okay, in this case, we have to create a clay robot. So we are in a slightly different configuration. We still take the I do nothing and we add one more clay robot and we reduce the resources by how much a clay robot costs. Too many dashes. Then we have a different for the obsidian robot.
So basically,
Also,
just to recap.
Sorry, go on.
Go ahead. No, go ahead.
I was saying that in this clipboard, in this machine, I don't have a clipboard manager. Typically, all this copy and paste back and forth, I don't have to do them because I have clipboard managers. But yeah, sorry guys. My normal machine died, so so we have one additional obsidian robot. And you were saying instead?
I was trying to do a quick recap. So basically, because we are trying to simulate all the possible games, meaning that you start from an initial state, at every iteration you can do one of many moves, but we want to simulate all the possible evolutions of the game. So we are pushing into a stack for every step all the possible moves. And basically, here is the logic where we are creating a new move. We have a state that is fixed for that loop, and we derive from that state what will be the state if we do that particular move and push that new state into the stack.
We can do the particular move, because this if is guarding that we have enough resources to do a particular move. Yeah. because
Okay.
you don't have the resources, you can't do the particular move.
Mm-hmm.
Okay, I need this guy. No, there. I need that guy. This guy is adding a Geot robot. Obviously, if I didn't wrote stuff wrong, because then we will have to debug if I did something wrong, or if it's not compiling.
Mm-hmm.
And we remove the obsidian resources. I think this is, we have to return red max. We are already doing that. Okay, let's try that. Are we confident?
A quick question: did we implement caching with that hash? Right, we did. Meaning,
What do you mean by caching?
if we end up in the same state, in a state that we have
We
already
are not
explored.
going on, because I mean, we are looking for a max. So if we already seen the state, it means that cool. The other state will arrive to the same max. So
Exactly,
let's not go down this route. The only problem is that we are cloning there instead of having a reference, but we are cloning integers. So I don't think this operation is going to be massive.
Mm-hmm.
So let's
Okay,
just
so
do
you
whatever.
do the caching there in line 114, basically. If that state is
Yeah.
already in our history of states, just keep this loop.
Okay, good news, it compiled. Okay, you can see that is, if you remember the run for Python in 99 seconds, this is going to take less.
Seems a bit faster.
Seems a bit faster.
But are the values correct?
Let's see. We have our 1400s and I don't remember. Yeah, the number is correct. On my other machine, this was taking 6 seconds, 23. I have to say that this machine is quite slower, because the Python one was taking 60 and the last one was taking 6. Yeah, this machine is going a little bit slower. But anyway, we have seen that we made in Rust the same algorithm with some binding of parameters and having the same result in less time. We can improve the solution a little bit too, again. 24, what was before 23? I don't remember. But well, still, 99 to 25 is 1/4 of the time. We could try to do an experiment. Just give me a browser for a second. Oh my God, sorry, wrong page. Give me a browser. Yes. No. Yeah. Control L. I don't remember the syntax by memory, so I want to do the loop in a parallel fashion.
Okay.
Calling Rust, but we do the parallel fashion in Python.
Mm-hmm.
Okay. So let import pool.
So this is possible just because every row in our input file is an independent game, right? So we can simulate them independent.
It's an independent game, exactly. So we can simulate that.
Okay, so in Rust we are able to do a simulation for one game. Here with Python we are just coordinating, doing all the simulation in that file, and we are trying now to parallelize stuff.
Yeah, exactly. So how do we do that? Parallel function. Let's see what we have, because multiprocess pool is a little bit, peaky. Let's say peaky. Yeah, it's a good phrase. Our return value is equal to what? To a sum of what? It's a sum of our pool.map. So here we are giving a function and parameters to that function. The parameters to the function are our enumerated lines. This will go in the function as a single parameter, if I'm not wrong. Oops. Okay. Here we have to return.
In Python, you cannot destructure in the function arguments, right?
No, I don't think so. We can try later, but I don't think so. And this n is our run last. Okay, here we have a function that takes the blueprint and this index, and it returns the run of the simulation multiplied by the index plus 1. Is returning here is summing all of them inside the ret. So this code is not needed anymore. We can comment that for now. Let's see what I got wrong, because for sure I made a typo somewhere. It's impossible that this guy is running the first time.
You're not printing anything? Or just at the
not
end?
printing anything. Yeah, no, it's just at the end. So yes, let's do this.
But it is faster, much faster.
Let's do like this if we want to print while it works.
Okay, now in theory we should see things in a potentially different order, right?
Yeah, difference from before is that we will see stuff in random orders. Same result, less time. Instead of 25, 10. The number of workers here depends on the core of the CPU, depends on a bunch of stuff. Rising it too much can make stuff slower, can make stuff faster, depends on the CPU cores that you have. Okay? But anyway, now, all of this is running in parallel. The orchestration of the parallelization is made by Python, and this parallel function is called in Rust. Okay?
Nice. Okay, so from the Python perspective, it's something like it's just an implementation detail. You don't even know that it is done in Rust, basically. Could be any library.
Yeah.
From the Rust perspective, yeah, you do have a library, basically. From the Rust perspective, instead, it's a bit painful because you need to accept Python types, so you need to do all the handling of
yeah. Here we accepted a U32 because we are passing an integer. And here is expecting a Python dictionary. And then decomposing the stuff from the Python dictionary, yes, is a little bit painful.
Okay. Yes.
But if you stay with more low-level types, it's easier to handle them. And the result is handled by, if you don't have to pass back Python objects, in this case we are passing back an integer, you can say that the function return a Python result of the integer type that you want to return. If you want to return a dictionary, then you have to
construct
return. Yeah, exactly. You have to do more complicated stuff. For example, I don't have it open anymore, but if you look in the PyO3, let's go back to PyO3 then. PyO3, let's see if this is smart. Loading. Here there are a bunch of projects that use this, and I go to again hyperjson, sorry. Because if you go here, it's constructing dictionaries and returning dictionaries.
What happens if you return a Rust type? It's just gonna complain, right?
You always have to wrap the result with a Py result. Then you can have a Rust type in there. But it must always be a Pi result.
But if inside PyResult you put, I don't know, your own struct, your own Rust
Or
struct,
your own struct.
like
No
state,
idea.
right?
Do we want to try? Let's return this and update.
Yeah, let's
There is a
return last
tuple
state.
struct. Just the last state.
Yeah.
Okay,
Just because
obviously.
we have it already. I don't know if it's.
I don't know if we have already because we are outside of the loop.
Oh, right, right.
You
Well, we
can
can
return the
we can
first.
we can build a default state. Let's just derive default in the state, which is going to be a state with alt 0. And now at the end, you can just return default to default. Well, you should do a pi result, right? Default.
Okay. We want a default.
Mm-hmm. I think it will understand from the return type that this is a default of a state. Otherwise, you can do state column default.
Okay, the Python code now is not getting an integer anymore, so it will print here and probably it will crash here.
Okay, yeah. Because this is not a dictionary anymore. This is a type that makes sense only in Rust. So
Oh no,
let's
I have
see.
to compile, sorry.
Let's see what kind of behavior do we get.
No, it's not compiling. We have to implement some trait. The trait bound is not satisfied.
But what is the trait bound? State by error.
So let's look here.
I think it's that OK wrap that doesn't like it.
The trait state is not satisfied.
So that result state by error, I think, is that pi result. I think pi result is just an alias for result something by
okay.
error.
Yeah, result something.
But then
The
OK
trait
wrap, we don't know what it is.
Okay, no idea how to do that. Oh, in theory, my opinion is possible, or you have to create you could create a named tuple, a Python named tuple, and I was about to show that here the guy is creating complicated Python objects. Where is it? I saw that somewhere. You have the Py interpreter as an option that you can have even in our code. We pass the Python interpreter down here. This is the Python interpreter. So with this underlying Python variable, you can create Python objects and return them. Or probably you have to implement some kind of trait on your struct, but I have no idea.
Yeah, I found here a documentation page that explains exactly
How to do that.
what are the default conversions, and then there is conversion traits. Where
What
I
do we
think...
implement?
No, I wouldn't do it now, but I mean, it should be possible.
Okay.
If you want to do... Yeah, there is a trait called into Py that you can implement to define
How to go to Python, okay.
Exactly, yeah. So you could probably create a dictionary for this struct, and then you can just return that struct, but on the other side in Python you will see it already as a Python dictionary.
Or a Python tuple, or a Python list, or what you choose.
Exactly.
Okay. Nothing. Are we back to a working state? Let me just check if we are back to a
Meanwhile, I'm
working.
going to drop these links in the chat if anyone is curious.
So, yes, still working. Cool. I think for today is enough. What do you think?
I think so. Yeah, we will have a repository with all this code.
Yeah, we will push all of this to a repository.
And as usual, we will publish everything in YouTube, so you can find the recording there. Hopefully, we will be able to fix the quality a little bit. I don't know. I cannot guarantee it, but if we can, we will try to publish it at a slightly better quality. And thank you for all the feedback on the quality issue, because next time we'll try to be a little bit more prepared, and hopefully the video quality will be a little bit better.
And our connection will work better.
Exactly. Yeah. Okay, so thank you very much, everyone, for being with us. And we will do a super quick raid, if I can do that. So, yeah, thank you very much. See you next time.